his exposure to design is really long. Same is the case with Gowthaman as well. Okay, and Kenneth is presently associated with WorldViz, right? A company which works on interaction design, VR, virtual reality, augmented reality, all that stuff. And if I'm recalling well, right from his internship, and he had also a short internship association with Bosch Germany, correct? Huh?
Yeah, yes, sir.
Okay, right. So I think his exposure to design and HCI, that's on the entire gamut is really wide. And Gowthaman is also a staunch design enthusiast, right? And Gautam is actually on the verge of proceeding for his highest, or he's started his highest studies in MS in HCA with an Australian university, right? And Kenneth is on his way to Simon Fraser University, Canada, correct? Right?
Yeah, yes, sir.
And I think this is the way I think. I think they are still first year students for me, right? That is the way I see, but they are all tremendous. Their exposure is tremendous in these areas. He recently had got an admit from Simon Fraser University, Canada, specifically focusing on HCA research. I think it is something related to MS interaction systems or something, right?
Yeah.
And to my knowledge, Simon Fraser University is a very long trusted university. They are very noted for their research in design and data sciences and all. Okay, right? Their intent, which I gave them, right? People should understand the variety of paradigms or various interaction design paradigms available in the literature, right? Kenneth, don't think I'm eating into your time.
No,
2
sir,
minutes,
nothing
2 minutes to motivate the audience for this, right? See, all of us, we sit with the assumption that we should create a beautiful, colorful interface. What is the anger on color for you? Somebody is asking me. No personal anger against any color at all, but there is a strong misnomer or misconception that any product should have only GUI. Graphical user interface is order of the day. And I agree, naive end users, preliminary end users, and all GUI helps. Okay, but I don't know how many of you have heard of this. I'll put it in the chat. There is also one more classical type of interface called as the command line interface. Okay.
Yeah.
1 minute, I have to paste it in the other room also. They will talk in depth, right? But I'm just pitching the importance of this session. Okay.
Yeah.
Right. Technical audience, right? Technical audience, I mean, let's say I'm using a developer beautifully. Balayogi, you took that word from my mouth. Engineering audience and all, if you're developing a product like MATLAB or Scilab or something, right? They don't need GUI to the extent end users need, naive end users. Okay. Why? Because I don't know how many of you have observed this trend. Yeah, CLA is nothing but your DOS prompt here in command prompt, DOS prompt we call in Windows. Right? Technical people, they are quite comfortable in interacting with the system at command level. They can remember commands quickly, they can get them tasks quickly. System administrators, okay. System admins, right? I think you understand what I mean with system admins. People who create your login, network user, login, all that stuff, right? Windows gives them beautiful GUI to create accounts and all. I am the Google setup, okay. We never use the GUI. We use a script at the back end to execute one command. It will insert 1,000 users for me, one search. Okay, right? So technical audience, they may be still comfortable with CLI. Okay, so that is where our role as a designer is. Whom are you developing it for? Choose the appropriate paradigm of interaction. I've only told two. CLI is one paradigm, GUI is one more. They will forms are another one more, right? I don't know how many of you recall when we used to book railway tickets physically in the counter. Okay, I don't know. I think the modern audience may not know. The elderly people they may connect well with me. Earlier days, to book a railway ticket, right? My father used to send me to the railway station when I was 5th standard or 6th standard. Okay, long queue in the central station. You have to stand. How many of you observed the speed at which the operator there, right? He used to book tickets right at the rate of knots. If you go and at least one day I managed to see what is there on the screen. This terminal was only a form fill-in interface. It was not GUI and all. Okay, form fill-ins. The tab key is the most powerful key, right? They just will keep pressing the tab key to hit the data you give, train number, passenger number, all that stuff. Now, why I'm highlighting this is graphical user interfaces, right, can become time consuming. Why I'm telling is, yeah, it exists. You go and tell the telephone department clerk or the railway department clerk, book it using a smartphone, he'll throw back the smartphone at your face. Right, the form fill-in is spot on and quick for him. Okay, Right? Just one more issue in this, then Kenneth will take over. What is the user issue or developers, right? What is the time they feel? The interaction time with the GUI setup, right? The mouse and all. If your tool is heavily dependent on the mouse, 1 minute, I'll put it on the other chat. If your tool is heavily dependent on the mouse, of your interaction based paradigm is heavily dependent on the mouse, then this hand-eye coordination comes as an issue. Okay, see, we people are quite smart here. We feel mouse as a non-existent entity. For me, I don't know, still the laptop mouse is a big headache for me. Okay, that mouse pad which they give in the laptop, I'm not comfortable with it. So we plug in an Excel mouse. But the cognitive people's observation is when there is a next device called a mouse, right? People find there is some time lost in the hand and eye coordination. Okay, I'll tell you my personal experience. One day in a post office, right? This was long back. He was actually lifting the mouse from one place of the mouse pad to the next place. Right? I hope the sound is audible now. Okay. Mouse is a movable entity. We all do it. So that is why I'm pitching the case that don't think always we should create only GUI. Some cases even CLA could be the order of the day. In some cases, form films could be the order of the day. Right? So this is what we call as interaction design paradigms. Okay. They both are experts. Right? I leave the session open to Kenneth to start over.
Yeah, always.
Thank you, Kenneth. Sorry for eating your time.
No problem, sir. I just share my screen.
Yeah. Old people, if they tell long stories, people like it. Okay. Go ahead.
1 second. I'm just sharing my screen. Yeah, I hope you guys can see the screen.
Yes.
Yeah, all right, great. So we'll begin. Today's session is going to be about interaction design paradigms. And so welcome to the second session of the Human Factors in Software Design workshop. And so in this session, I'll be talking about related topics and just explaining a brief history and the relevant fields related to interaction design right now. So the presenters for this will be myself, Kenneth, and Gautam. I'm not sure if sir, like if you guys didn't hear sir's intro, I've had personal experience, like almost 3 years of experience in virtual reality, working in designing and developing for VR. And I've also done a couple workshops with Facebook and MIT in augmented reality. So I've pretty much been in the field for the last 3 to 4 years in HCI, and now I'm pursuing a Master of Science in the same field in Simon Fraser. And Gautam, are you on the call? Do you want to do your intro? Okay, I think he's not yet.
Yeah, sorry, I had some internet issues. So am I audible now? Yeah, so good morning, everyone. I'm Gowthaman, and I think Sir spoke on behalf of both of us. He's introduced us, so I won't waste any time on this. So I'll just be starting my master's in HCI in the University of Melbourne in Australia. And yeah, we have a very nice session coming up for you. So hope you guys enjoy it.
So the first topic we'll be talking about is the eras of interaction design. So we feel like, it's better to preface our session with the history and how it's built with time. So like computers have undergone multiple, numerous transformations in the way they work. So, and it's very important to know how they've changed so that to underscore the importance of how human factors have played into this. So we start at the early 1960s, where things were quite mechanical. Computers were basically punch card machines where you manually insert punch card with code, and this was incredibly crude, and the computing abilities at the time were extremely rudimentary. So it was basically only scientists and researchers who were experimenting and building computers at the stage. And it was vacuum tubes, relays, and diodes. There was no concept of software at that time. It was pretty much just a hardware device, and that was a computer. So as you would expect, there were underdeveloped I/O channels. There was no form of interaction at all, and there was no feedbacks or affordances, the terms which we will talk about soon. So a modality is a term which describes a channel of sensory input and output, and that was something which was non-existent in this era. So then you move on to the 1970s, and it was the first time people started seeing a command line interface. So command line was at the time just the primary form of input. So computers had a display, but for the first time they were taking and like they were including human factors in it. So the user could type in code and they would get instant feedback. And even though this wasn't much, it wasn't like truly interactive or scalable. It was you needed a lot of technical knowledge to use the computer, but it was a big turning point in this era, since it came with the display, and it was providing basically a conversation between man and machine. So that was the first thing which changed in the 1970s, and that basically enabled real-time interactions. So basically dynamic interactions via keyboard. And also the modality which I mentioned before also became a lot clearer. So there were better manipulation methods and there was better feedback. You could see on the display what the computer is processing and what is it giving as an output to you. This paved way for a lot, like much better affordances. So at this point, computers had started, like they had started to become personal. They were experiences targeted towards users, and there was a trend which would follow with lower usability barriers. So it was enabling more people to utilize this software instead of just researchers and scientists. So then we go to the 1980s. This was revolutionary because this was when GUIs were introduced. So graphical user interfaces, for the first time, they were introducing the idea of a computer for the general consumer. So they were personal computers. So companies like Apple grew at the stage with the Apple II and eventually the Macintosh. They introduced keyboard and mouse interactions where people could move windows around, and so this spawned operating systems like Windows, which we still use. Most of the world still uses that. So the 1980s was revolutionary. It was the first time people were able to have a personalized experience. They could configure their computers to work the way they wanted it to. And it also was the era, the technological advancements at that point were enabled like a color screen, and there was instant feedback via multiple peripherals. There was a keyboard and a mouse, and both of them could do direct manipulation on the display. So this was a standardized I/O channel. There was input and output being given through the machine, and also there was a sense of visual intuitiveness. So all of the windows which were available would be able to be moved around by dragging it around, and there was a lot of skeuomorphism to basically mimic real world elements with files and folders, etc. So then in the 1990s, as computers grew, we reached a point in network development where the internet was a thing. So the internet was a huge shakeup. It was basically providing a highway of information to everyone who was on a computer. And the usability principles started to mature because now people were having standardized experiences. There was the same web page will be seen by multiple people. So if you see Wikipedia, the same person is going to be seeing that page too. So it has to be standardized across different platforms. And so this started developing, basically leading to what the previous session was about, web usability guidelines. So it basically started the process of studying cognitive psychology and ergonomics and other human factors in relation to the internet. So what that changed basically was there was a complete role reversal, as like compared to the previous computing era. It was more social. People were, people could share things to each other. People were able to talk to each other, and there was a very communal experience. So everything on the internet was something which, it was public and people could all visit it. So that was one thing which changed, and it was also extremely user centered. So it was something which was people, instead of people adapting to the system, it switched the thing where the system started adapting to the user with updated web pages and everything. So then this went on, computers grew all the way through the 1990s, and in the 2000s we were introduced to the touchscreen form of interactions. So there were obviously mobile phones also existed before, but they were basically just pieces of buttons, plastic, where you press buttons and you interact with them. And then finally a new form of interaction was introduced in the 2000s, especially the iPhone's multi-touch. So multi-touch displays enabled users to do certain interactions which were not possible before. It was something which eventually went to tablets and even laptops nowadays, but it was the most user friendly. So basically it allowed for the user, even without any knowledge of a computer, they knew that like how in real world they could pinch a device to expand it, they could do the same thing over here. They could do they scroll by just swiping on the screen. So it was the most natural form of interaction among all of the other, based on history at that time. Instead of using a keyboard and a mouse to change things on a screen, you were directly changing the screen with your fingers. So this was another game-changing factor. As we all know, smartphones are super common right now. And then in the 2010s, we started moving, to expand the experience which our smartphones are providing, and also solving other issues. So wearables started being a thing, where things like Google Fit and Apple Watch and all these things have started becoming so commercial. Fitbit, and at this point it's almost every second or third person has some form of a wristband or a fitness tracker. So what this enabled basically was, it also allowed for like a very minimal learning curve. When you use a smartwatch, you don't really need to learn much. It does everything on its own. So that was a form of, it was a paradigm which was new. It was something which was reducing the interaction, and it was contextually aware. It was able to provide you with information automatically. It'll automatically track your heart rate. It'll automatically track your fitness routines and your exercises. And also it basically, since it is always on your hand, it ended up being very useful for universal design and people with disabilities and accessible, basically providing accessibility to a wider range of people. So it was something, a computer on your wrist practically. So this was another huge change in the paradigm. And along with this, there's also been a huge rise in immersive technology. So immersive technology includes AR and VR. We'll be talking about this a little later on, but basically, yeah, immersive technology includes virtual reality and augmented reality, and they've been building, and they've pretty much every smartphone we have right now available in the market has support for AR. Things like Snapchat filters, Instagram filters, and all the way to proper professional 3D imaging. Right now, people use it to scan objects and make them into 3D for games and everything. So what it provided was, it has the widest range of feedback. So when you use a VR headset, for example, you get almost every form of feedback which you would get in the real world. You get haptic feedback, you get visual feedback, 360 view of visual feedback, and you get auditory feedback. And it practically, what it does is it substitutes your environment. What you have around you is replaced by another environment, a virtual one or an augmented one, where it will manipulate your real world with certain filters and all of that. And also how direct manipulation allowed for in 2D direct manipulation was happening on a screen. Now in immersive technology, you could do 3D direct manipulation, where you're able to move things around in a 3D space. So yeah, I'll hand it over to Gautam now, who will talk about the fundamentals of interaction. So let me just stop sharing my screen.
Yeah, just give me a minute. Okay, I think my screen is visible now, right?
Yeah.
All right. So yeah, Kenneth has explained or just went over all the interaction design paradigms and how they've developed. And moving forward, when we talk in depth about these interaction design paradigms, one thing we need to know is the fundamentals. So just the basics involved in any interaction design paradigm. So that's what I'll be talking about. So in this whole thing, what we in this industry do, or what the research does, is we try to model how a human interacts with a computer. Although it may sound simple on paper, it's actually a bit more complex than that. So to help understand that, there are that we need first just go through. So modality is an important one. It simply can be described as a channel of sensory input and output. So a touchscreen is a modality where you give inputs on a screen. It's a capacitive screen, so you can use multi-touch. And the output from that is given on the same screen as well. So that is described as a modality. And affordance is also a term that you'll see thrown around a lot in this literature as well, which is it's a characteristic or an attribute of an object that tells what its potential use is. So if you have a button that says save on it, all it does is save progress or save a document or something like that. So the affordance is clear right away. Then after that, you have inputs and outputs. So these are pretty self-explanatory. Inputs is what you give, an instruction that you give to the computer, and output is what the computer does with it. And feedback is also a type of output. It's a type of output that is in direct response to your input. So it's just the computer's way of telling you that I have acknowledged your input. So when we model any human-computer interaction, specifically, we have something called a modality loop. So we can think of this as just a cycle of input and output with the help of affordances and feedback. So a modality loop always starts with the first phase of the affordance phase. And this is where a user discovers what they can do with respect to the interface. So this is buttons and, whatever that, it depends on the paradigm, what the type of input is, but it's just the affordance phase is where you discover what you can do. The second is the input phase, where the user, once they understand what they can do, they used to use that to give inputs to get their task done. And the third one is the feedback and the confirmation phase. So the computer acknowledges that they've got an input, and then it does the necessary processing or whatever it does, and it gives you back an output and feedback as well. So to better understand this, I thought I'll explain it with another modality, which is using a controller for video games. So this is something you hold in both hands. And usually in this stage, when you play a video game, there would be the affordance phase would be highly visual in nature. As you can see, it's mostly orange with a bit of audio as well. So visuals and audio play a big role in the affordance phase. So when you start it up, there would be a tutorial telling you what each button does. So that helps with the discovery. It helps you get acquainted with what all you can do in that interface. The input for this specific modality, which is through a controller, is purely physical. Buttons that you're pressing on the controller itself. And the feedback stage is where it kind of just confirms that these inputs have been registered. Visually, it would show you, because your character would be moving on screen. And It might also have haptic feedback to let you know what you're doing is right. So that's termed as physical. And again, audio also comes into play over here as a form of feedback. So when you talk about modality loop, we also talk about information that the computer tells us. And visuals are the most information dense, and they're also the most time consuming because you have to read what's happening on screen, on the interface. You have to understand it, and you have to keep it in mind. Audio and physical, which is haptics, take a lot less time, but they also tell you the least amount of information. Because by virtue of haptics, they cannot tell you much information. So audio would be something like a beep or a positive sound to let you know that you've done something right. And maybe if you do something wrong, your haptics, the controller would vibrate violently to let you know that what you're doing is wrong. So it's least information for haptics, but it's also the least time consuming for you to understand. Audio gives a bit more information, but it takes a bit more time for you to understand, while visuals is on the extreme, where it takes the most amount of time for you to understand and for the computer to tell you what's happening. So yeah, when you talk about HCI, we cannot skip over what a mental model is. This is something that almost all the paradigms that we'll talk about. So they play an extremely important and crucial role in HCI and interaction design. So what it basically means is it models how a user perceives the world around them and their internal beliefs as a concept. So why is this important for you as a designer or a researcher is if you can understand your mental model of your users, if you can understand the mental model of your users, you can use these models with your design and they would be successful right away. It will make them usable and intuitive from day one because you're using an established mental model that users are familiar with. So over here, we can see what streaming services use. This is the mental model that they have and what users have as well. So you have the album art, which tells you which song is playing from which artist. The media controls play, pause, shuffle, and loop, as well as you have a toggle and sliders for your volume control and sharing options. So this is what a user expects when they start using a streaming service. And if you are designing a music streaming service, and if you don't use this mental model, your users will have a hard time just trying to get around using your interface. So there are a couple of things that you need to keep in mind when we talk about mental models is that they are not static. They always change. They've always been changing ever since HCI became a science itself. They're capable of evolution. So it always gets better and better as time goes on. You're playing around with pre-existing notions of a user, and when they start using a service, when they start using an app, an interface, they always have expectations in mind based on their previous experiences. So when they start using a banking website, they have experience with other banking sites. So when they come into this, they have expectations, and we should fulfill those expectations. When you deny those expectations, the user experience just ends up bad. They start struggling to do tasks, and it won't be enjoyable for them. Again, consistency is key. So for specific tasks, it's been done in a certain way. For example, when you talk about a streaming service, people always expect it that way. You don't need to reinvent the wheel every time. So if you're doing a streaming service, just use the one that exists, and it will be good to go. Yeah, so just to illustrate those points, consistency is key, right? So Command-C and Control-C for macOS and Windows respectively always copies data. So whether you're talking about files, whether you're talking about images or text in a document, throughout the operating system, all it does is copy. Throughout every app you use, all it does is copy. So this is consistency. And it's very hard to change a mental model. I mean, I think all of us have heard of QWERTY. That's the keyboard all of us use. Even though Dvorak is a more efficient implementation. It's on paper, it's faster. People just won't use it because we have a mental model for a keyboard, and that is QWERTY. So we just have to play within those confines of what users expect. And violating that is just a very bad move. Right, so I hope you guys understood that well. So moving forward, we just want to talk about relevant interaction styles that we use today. So computing has become very mainstream, it's ubiquitous, it's everywhere. And for that reason, we have several different types of computers, and each of these have their own interaction paradigms, their own modality loops. So I just want to talk about why they're successful and why they work for the certain functionalities that we use them for. So the first one is the oldest and the most experienced type of computer, so to speak, which is the desktop. It's been around for the longest time. When we talk about the UI UX maturity level, it's at a very high stage because GUI has been around for decades now. So desktops, just due to their power and their input methods, are the preferred platform for multitasking and productivity workloads. And they run operating systems like Linux, Microsoft, Mac OS. And what's interesting to note is all these three operating systems, they don't change their UI much, or the user experience stays consistent throughout time. So what this tells us is they've reached a stage of maturity where they can only make tiny incremental changes. There's no need for radical visual revamps because they've pretty much perfected what their use case scenario will be with respect to the user interface. So I think Sir explained this before a bit. So CLIs is how desktops started out with. And in modern day operating systems, CLI and GUI coexist together. So the issue with CLI is that it's too basic. It's archaic in the way it looks, but we have to acknowledge that it is incredibly powerful in the hands of an expert user. But not all of us are expert users. So computing could not have gone mainstream as it did without a GUI. So why was the GUI successful? Because it exploits the display well. So the environment that a visual canvas, it exploits it well spatially. It does it using images. It does it doing fancy text, fancy animations that give us a sense of place. It does it with iconography, which is quite important. So put together, they exploit that visual environment well. And it shows these clues that triggers natural responses. So moving a file is much easier to see visually. You can just see the file moving rather than a progress bar inside a command line, which doesn't help much. It doesn't tell you about what's going on. So it's just a lot more user-friendly. Just seeing what's happening is a lot more user-friendly than just a command line telling you what's going on, which is just textual. So yeah, how was this? So how did GUI start out? So it started out with skeuomorphism mostly. Mimicking our physical world in the digital world was a revolutionary step because it just exploited all of the notions that we had. So a place where files would go to be deleted would be called a recycle bin, just like what we have in real life. And we are really good at just recognizing these things right away. It's always inherent in our mind. So skeuomorphism with respect to things like the recycle bin, a toggle, a switch is something that we see day to day in our lives, and we also see it in our operating systems. So for that reason, the skeuomorphic UI elements are incredibly effective. And many of those aspects have been used since the 1980s itself. They've become the industry standard. A toggle is always a toggle. And for fine-tune control, you always have a slider. Those things have not been replaced at all. Again, these things are derived from their real-world counterparts. And they don't always have to be a visual one-to-one copy. They can be a metaphor. You have to somehow relate your physical world and the digital world. And this is where Windows came into play. So just like how on a desk you would have a bunch of files, that's how we replicate that in a window itself on an operating system. You have files that you can see, that you can interact with. So that's what a metaphor is. It's one of the most successful metaphors that we've seen so far. And compared to a CLI where you would have to chain a bunch of commands to see what files are there, then chain another bunch of commands to interact with them, a GUI is just a no-brainer for most casual users. And now desktops are pretty unique because even though CLI and GUI are two different paradigms, they coexist together in modern operating systems. They cater towards different users. So CLI, I think Sir mentioned it as well, it's very high precision and there's low computational overhead, which means it's just a lot quicker. So power users can really exploit that to their advantage. So over here we have Slack. It's a screenshot of Slack, which is a very popular and powerful business communication platform. So where they have these channels where people talk, I think many of us have used Slack as well. So instead of using a GUI for choosing a contact and choosing to message them directly, you can just chain commands directly inside the chat box. And this is so much quicker than what would take 5 or 6 button presses to get done. And this is just a few clicks of a keyboard. And they can even set custom commands. If you're in an organization, you can set custom commands for your organization as well. So this is incredibly powerful. You're using CLI and GUI very, very effectively. And this is something that is very cool. So after that, smartphones and tablets are the most popular class of devices we have today. These came in the late 2000s. So this was by the time where we had a good handle on how user interfaces worked, right? Because desktops came at the time when HCI was just starting to become a community, and now it's become a fully fledged field. So most of the smartphones and tablets were able to hit the ground running with respect to good user interfaces and good user experiences. So just like how we had a mouse for a tracking device, now we have a much better tracking and pointing device, which is our finger itself. And we can even use multiple fingers to get things done. So a smartphone was a device which just fit in your hand well. And for this reason, it was going to be super personal. Feedback would be done visually in terms of audio and with haptic feedback, since you're always holding it. So these three together would make for a very effective modality loop, especially with the feedback stage. And smartphones, just the way they were designed, they have a bunch of internet radios and GPS equipment inside it. They also have compass, altimeters. And what these sensors do is that they make the smartphone aware of its surrounding, aware of where it is. And this is something we had not seen before with the desktop. So each paradigm brings something new to the table. It helps make our life easier. So for this reason, the phone eventually became an extension of our body itself, because none of us can imagine without living life without a smartphone right now. So it's very useful as a companion device. The internet, having the phone and the internet on the go made it the perfect media consumption device. And it does not work too well for heavy productivity tasks. You can't multitask well on it. It's just not built for that. So each paradigm, again, has its use case scenarios. So when smartphones came around, there was actually a huge conundrum. The HCI community did not know how to adapt an interface to touch, because for 20 odd years, we had only used a keyboard and a mouse in the mainstream, and they just didn't know how to do it well for touch. So this is where multi-touch comes into play. So what would be a left click using a mouse just became a tap to click, which is so much easier. instead of pressing Control and plus to zoom in on a picture or a web page, you would just zoom in using your fingers, which is just so much more intuitive and natural. It just comes to you directly. And even rotating with 2 fingers, something that would take multiple button presses on a desktop, you could just do it instantly on a phone. So we replaced a bit of time-consuming gestures, time-consuming steps with really quick gestures, and this has to play a huge part in what made smartphones and tablets so successful, is that they adapted to touch well. Touchscreen interfaces are nothing new. They've existed in the 90s and early 2000s, but nobody could implement them effectively. And smartphones and tablets did that right, because we can easily replace a desktop interaction paradigm with it for most users. So as smartphones started to mature, they got more powerful, processing got a lot more compact and power efficient. And natural language processing was something that was possible on the go. So with that, we're introducing a new modality loop as well, which was voice. So voice is something that is very natural to all of us, since we are social beings. And for that reason, digital assistants like Siri and Google Assistants, as we've shown here, became super popular. People loved using it because things that would take maybe 5 to 6 or 8 steps, you had to unlock your phone. If you wanted to set an alarm, you had to unlock your phone, go to the alarm app, you had to pull up those sliders, you had to scroll through time and all that. Instead, just using a click, you could tell your assistant right away to set an alarm. So as a modality, for certain tasks, voice is so much more superior to anything else that we can do on a smartphone. So what we're seeing is just the number of interactions that we have with a device to get something done, it keeps decreasing. So for a specific task, it would be maybe 5 to 6 steps on desktop. Then it would be 3 to 2 steps using a touch interface. And it would become 1 step using voice as a modality. So that is something that we see moving forward with each paradigm. Tablets, they kind of started out as supersized smartphones, but they found their own niche with media consumption. Just because you have such a huge screen, it's a lot easier to watch movies, read newspapers, read books on it. And due to the larger screen, you were also able to exploit multi-touch gestures well. So you could use 4 or 5 fingers for switching between apps, going to the home screen, and things like that. Smartphone and tablet UI are something that is still in flux. They haven't matured as much as desktops. So they keep changing as the market keeps changing. So what we see now is tablets, they get a lot faster. And we are sort of coming full circle in a way. And tablets are becoming more like desktops, where they attach to external accessories. Now you can plug a keyboard and a mouse into it, which nobody thought they would do when they started out developing interfaces for tablets. And now everything is just coming around full circle, where it's just a more portable desktop in a way. So the industry, it keeps changing the interfaces, the user experience, it keeps responding to what the market is, what the demand is. It hasn't matured as much as we would like to think it is. But moving forward, we are sure to see some more interesting changes in this paradigm. So smartwatches, pretty popular these days. Earlier, I had mentioned how smartphones have become aware of their surroundings, right, with all those sensors and stuff. And now smartphones take that to the next level. They're super aware of their surroundings. And the barrier of usability, or the technological barrier, has become so low. Smartphones just become part of your body right away. They're getting faster and powerful by the day. Again, this is a very young market. The industry, in many ways, is pretty immature. And one thing to note, I think Kenneth said it as well, is that it's a total flip of how we see the modality loop. the input stage of the modality loop was always us consciously giving an input for getting a task done. And a smartwatch just flips it on its head. It always takes input from our body. So if you have a heart rate sensor, we never had to ask it to sense the heart rate. It's always doing that in the background. So it's taking inputs without us consciously having to input it. It intelligently analyzes this data and it presents it to us in a very friendly way when we need it. So that's what is special about smartwatches as a paradigm. So yeah, they come with a bunch of fancy sensors. It is amazing how they fit all the sensors inside such a small body. Again, it's a product of the technology of its time. It wouldn't have been possible 10 years ago or 15 years ago. So we have, on a modern smartwatch these days, we have a bunch of sensors that assist with health informatics. So heart rate sensors, quite common. They always keep checking for your heart rate. They're always polling your heart rate to let you know if something is wrong. Along with that, it also does activity tracking. Using motion sensors and microphone sensors, it does sleep tracking to let you know if you're getting good quality of sleep. Advanced smartwatches these days, the super advanced ones, they do blood O2 levels, so they can even check for oxygen in your blood. They can check the electrical signals in your heart using an ECG. So all of this is super complex. And the best part is all of it, they do it on their own without us even having to know it. Again, for noise, they have an omnidirectional microphone array, which is always checking for noise. And it'll tell you if it's too loud. And again, these are all things that could not have been done with a smartphone before. So each paradigm builds off the successes of the last one and also moves the whole industry forward in a bunch of ways. Yeah, so that's just my point. It's impossible with other paradigms, and it has to be automated. You can't expect a user to input this type of fine-grained data all the time. You can't expect a user to check for the heart rate and feed it back. It has to do it on its own. And that's the most user-friendly way to go about it. And it collects a lot of data. Data collection is just immense. And the way it works is it's always paired with your phone. So all the heavy computing is offloaded to your phone, while on the watch itself, it just does some basic tasks. And it's just concerned with collecting data and not processing it as much. But it is concerned with presenting that processed data back to you well. So that's where the paradigm is right now. This is always subject to change. I think in a few years, we can see smartwatches that are totally independent with processing power. It won't need to offload tasks to a phone. It can do all on its own, and that's pretty impressive. They also act as a contextual computing device. So this is something that just helps you in your day-to-day life, right? It's a quality of life improvement. So you can view notifications, you can see incoming calls, they can help you with navigating around. So you don't have to pull out your phone. It's right on your wrist. So it's a lot easier, it's a lot more user-friendly. And that's a trademark of this paradigm as well. It's just a quality of life improvement in many ways. And once you start using a wearable alongside your watch, the respective paradigms become intertwined. A user experience of a watch and a phone, they mix together. If one of them doesn't work, it hurts the experience of the other as well. So this is another cool thing to note about this paradigm. And that plays into contextual computing, which we will be talking about in depth towards the end of the session. And all in all, it's one of the most personal forms of computing we've seen so far. Like I said, the user experience community, it's still a bit underdeveloped for smartwatches. It's in its infancy, so to speak. And for that reason, many of us are not familiar with how to design for smartwatches. It's not something that we've come across because it's not as mainstream, as a smartphone. But soon it will be. So now I'll just be talking about how to design for smartwatches. Maybe go over some points that you can keep in mind moving forward. So the first thing is glanceable. All the best apps for smartwatches always they focus on quick interactions and these quick information snippets. Uh, People don't like to use smartwatches for too long, because you always have to hold up your wrist and then use it. So interactions that go on for more than 20 or 30 seconds, they become a hassle. And at that point, it's just better to do that task on your smartphone directly. Longer interactions, they end up with user fatigue, arm fatigue, and it's just not as enjoyable as it could be with these quick information bites that just tell you what you need and then you dismiss it and you move on. So a good rule of thumb is that interactions with a with a watch should always be measured in seconds. And maybe less than 10, less than 15 is ideal. More than that, it's not recommended. And all those tasks should just be handed off to a phone. Since we have such a small screen and you'll be using it outside in varying weather conditions, it's important to get font size, colors right. You have to make sure that the display is visible in all contrasting surroundings. So if you have a bright sunlight, you need to make sure that those colors can be visible. So your color choice cannot be arbitrary. It has to be an informed decision. Again, since the screen is so small, so there are certain fonts that are more effective on a smaller screen. We have to go for those, and we have to choose fit the information we are trying to display as well. So emphasizing important information is important. Again, because of that small screen, your visual grouping and the negative space you use have to be ideal. You cannot falter in that sense, right? Again, focused design is a trademark of smartwatch UI. So you cannot unnecessary content. Like I said, interactions have to be short and the information has to be concise. So let's say you're designing a companion app for a mail app. So if you have a Gmail app on the watch, you only show notifications as the mail comes in, and you show quick reply options such as thanks or I'll look into it. So, appropriate replies. Anything more than that, typing out a mail, all of that has to be handed off to a phone. You can't even let a user do it on a watch because then it's a failure of the designer itself. And again, minimal interactions. You don't want to be just tapping away at a watch all the time. So just, once you just see your screen, the notification should come up and you can just tap to dismiss it, or just a single tap to send a quick reply. So minimal interactions, concise information, and exclude all necessary content. And that should be a good basis for a smartwatch UI. Yeah, so responsive interactions, pretty much a no-brainer. You, again, want really quick performance out of it. People don't want to be holding up their watch for a long time if it's lagging or if it can't get data processing done. So any heavy operations, just hand it off to a phone. They can your phone and your watch communicates wirelessly. So just exploit that advantage that you have. Again, immediate actions that will all play into the whole experience. So navigation is quite important. People do use their phones for checking weather or even changing settings. And for that, you have to make sure your navigation is right. So page-based navigation is one of the best ways to do it. It's a simple swipe left or right. And for a screen of that size, and depending for most activities that you can do on a smartwatch, they just work well. And hierarchical is also a good way to do it, especially if you have, these child views that you want to show. Again, it's important that you don't clutter it. You don't throw all the options that you can, just the ones that you need. So you just get, a slider for a brightness toggle, things like that. Just keep it simple. Don't complicate it too much. All those other things that you want to change on a watch can be done on a phone. So we have to keep that in mind. And notifications, these devices are really good with delivering notifications. And again, like I said, they should be easy to dismiss. And utilizing haptics is quite important as well because it's right on your list. So consistency with visual design, since you're always using a phone with a smartwatch, you have to get the consistency right visually. So you have to be using the same colors, similar fonts, similar styles of interaction, similar animations, and all of this will help build a much more cohesive experience overall. So now I hand it off to Kenneth, who's a resident AR and VR expert. He has experience in this field for years, and he's much more qualified to talk about this topic. So, yeah.
Just a second, let me share my screen. Can you guys see my screen? I think it's still loading. Yeah. All right. So the last interactive design style I'll be talking about is augmented and virtual reality. So what's important to note is the difference between AR and VR. A lot of people get it confused or they don't really know why they are two different topics. So a good way to put it is like augmented reality adds digital elements to your real world. So you point your camera at what is around you, and then it will basically replace certain elements of your environment with things like filters, etc., as you can see on the left. Whereas VR, what it does is it completely replaces your environment. So it's a fully immersive experience where you are basically transported into another place where your visual feedback, your auditory feedback, everything is replaced. But there's also, it's good to note that there are also like mixed reality experiences. So there are experiences which combine both AR and VR and basically provide a mix of both. An example of that would be the HoloLens, Microsoft HoloLens, which uses augmented reality, but then also can completely replace your view with with the virtual environment. So that's the difference between the two. So let's talk about AR first. So augmented reality is capable, it's highly capable now, especially with how powerful our smartphones are. So it's able to do now hand tracking and face tracking, and it mostly deals with 3D assets. So these assets can be imported from existing video games and etc. So it's highly capable. And nowadays it's even able to do object capture, which is you can scan an object in 3D and then make it into a 3D object. You can also use motion capture for tracking all the bones in your body and mapping it to an existing 3D model. So all of this is like, you must have heard of motion capture in movies and all, and that's done with almost 22 points on the body where they put a green color suit and etc. But nowadays AR is able to do that within the capabilities of a smartphone itself without any sensors and all of that. So that's what it's capable of. So this is an example of motion capture, how it looks on an iPad. And so now that we know what it's capable of, it's important to know the guidelines when you design for AR. So the first, like the most important thing to note is the need. A lot of people don't consider this step, and it's important to note that you need to make sure that the problem you're trying to solve is something which can only be solved with AR. Because a lot of people tend to just for a gimmick purpose, they try to use augmented reality, and it's often the user doesn't really see the objective. So that brings me to the second point. So it's good to have a clear objective for the user. So the user, when they open up your application in augmented reality, they need to know exactly what it's for. It doesn't have to be convoluted or too many functions. So for example, the GIF which is playing on the left is of an IKEA via AR experience, where you can put any of their furniture in your house and see how it will look. So it's basically, it's got one function. It doesn't try to do more than that. It's got only one function, and it's clear when the person opens the app that that is what it's for. And comfort. So AR requires the user to move around a physical space. So it's important to note that the person is comfortable because they have to use their smartphone, move it around, and it's important that they're able to do that with ease. And also, last point to mention is hardware. So all this motion tracking or object tracking, object scanning, which I mentioned before, is capable only on like the highest end products which are there. So not everyone has the highest end smartphone or tablet. So it's important to know that whatever you build is capable on the largest possible set of hardware to realize what you're trying to do. So it doesn't have to be process intensive without any reason, but so that way more people can experience it. So the next important point when you do AR design is safety. So people often they get carried away when they're dealing with AR because all of your attention is trying to look through this window on your phone. So they don't really mind their surroundings at the time, and there's often you notice the person only staring at the camera to see what they're going through. And the fact that your experience will be changing what they see in the real world, it's important to test everything you make extensively in different environments. So make sure that there are no like as you can see on the left side, it's an example. This is by Google. In the rules, make sure that your app does not require the person to walk behind. They don't need to walk backwards. It's always forward, so that they have a peripheral view of what they're doing. Similarly, give users breaks because they can't keep using their phone or holding it up to see what you're trying to do. Make sure it's comfortable. So if you're, for example, making a stargazing app, for example, it doesn't have to be so that the user is always holding it up. They can also, should be able to hold it in their hand and also experience the same thing. And yeah, be wary of space. Be aware of how much space will be available for a user, and make sure there's minimal input because they're already holding up a phone to experience what you're trying to do. Make sure that you don't make the user also do a lot of tapping and all of that. It has to just be simple, single swipes and simple gestures. And so that's AR. So now if you go to virtual reality basically, it's like I mentioned, it's complete immersion. So the person will 100% get carried away. It's not like AR where there is even a peripheral vision of what's going on. The person will be completely in a different world. They'll forget that they're in the room where the table is and where the wall is. So how it does that is it does that using spatial feedback. All the audio you hear will be in surround. It'll be in actual relevance of where the audio is in your scene. And there's full body tracking nowadays, except it used to be headset and hands, but nowadays it's also there are also body trackers to completely recreate your presence in the virtual space. So again, designing for VR, since it's even more immersive, it can cause motion sickness. This is a very serious issue where since people are in a virtual, they're seeing something virtually, and it's covering their entire view. So if there is, for example, motion, even like in a video game, when you move forward, the camera will pan forward. If you try to do that in VR, since the body is not moving along with the camera, you'll start feeling motion sickness. It basically like how you feel on a roller coaster. So it will it will cause people to feel nauseous, and that's something you need to reduce. So make sure there are no smooth movements across an environment. It has to snap to different places. Also readability, since headsets, they how they work is they have a high resolution display, but they're also magnified using a magnifying glass. So at that distance, they need to you need to make sure your text is readable, because it will be pixelated in any of the lower end headsets. And simple ergonomics, just make sure it's easy to use in the space. Like you can try to make it like Iron Man, how they have these spaces. It uses the virtual space very smartly. And then finally, contextual UI. So since the person is moving around, you have another input. So apart from a smartphone, for example, where you have to touch to know what the user is trying to do, here you know where the person is standing. So you can make the environment reactive to where the person is standing. So that is contextual. So again, you need to make sure, safety wise, you have to be wary of how much the person can view at a time. So make sure you're not trying to overwhelm the user with content. So yeah, that's virtual reality. And now Gautam will just cover color theory, and we can move to the final topic after that.
All right. I hope my screen is visible now. Yeah, I think it is. All right. So we went through a bunch of paradigms earlier, even for AR and VR, and everywhere color theory is quite important. Right. So color theory in basic is just a guideline, a bunch of guidelines that you have to follow because you're designing for users, and color has a low level psychological impact on users as well. It's a matter of perception. People see it differently for sure, but overall, there is a tangible effect on user psychology when they're using a user interface. They love to see colors. It makes for a more fun and more enjoyable experience. And as a designer, as a researcher, understanding color psychology is a very important aspect of your profession itself. It's just not an arbitrary aesthetic choice. It has to be well reasoned and a well informed decision to use colors to decide on a color palette itself. A good color palette can totally elevate a good interface. If you have a well designed user interface, a well applied color theory will just elevate that to the next level. It'll make for a great user experience. And just an arbitrary one, you know, a not a not good color theory or a palette choice will just ruin it completely. And to create a good color scheme, you have to know a bunch of basics. And for that, first thing is the color wheel invented by Dr. Isaac Newton. It just tells you where the colors are and the complementary colors, the colors next to it. So this is just something you need to keep in mind. Sorry? Yeah. Oh, sorry about that. Just give me a minute. All right. Oh, really sorry about that. Yeah, I don't think you guys missed much. So I'm just getting into the main content now. All right, so this is just the color wheel. I'll just skip through this part because we have a lot of content to get through. So hue will just tell you what the dominant color family is. So this is what we commonly refer to as colors, red, green, blue, things like that. White, black, and gray are not considered colors technically for this. So tint is just you take a hue and you apply white to it. So that's what a tint is. It's important you use these terms right. A shade is just similar to a tint where you apply black to it. And again, all of these have minute psychological impacts on how a user sees color. So same goes for temperature. You can see that as blue as a hue. And towards the left, the colors get cooler. And towards the right, they get warmer. And warmer colors have a sense of intimacy, a sense of warmth itself. And cooler colors are considered more professional and again, these are things that you guys can research on your own. It's just too complex to get into right now. I can't cover all the basics at once. But as a designer, what you want to start out with is a monochromatic color palette. So this is to promote color harmony. And if you have one color with various hues, tones, and shades, it's a very solid interface from the get-go, especially if you use contrasting. White is a great contrast for any one color that you use. After that, you have what do you call an harmony, is where you use two colors that are right next to each other on the color wheel itself. So here we have blue and purple being used together, and that looks pretty solid too. Complementary is also a great way of getting color harmony right. For this, you need a bit more experience with creating successful color palettes. And this is colors that are opposite to each other on the color wheel. So we have blue and yellow and different hues and shades used. And again, it looks very visually pleasing. It makes contrast a guaranteed thing, because yellow on blue is such a great contrast for you to play with. And again, as you get more well-versed with how colors work, you can try something called split complementary, which is complementary. So you would use two colors and two colors on the other end of that color wheel. So you have blue, orange, and red being used here. Again, if you get bad, and the key is to get it right, it's trial and error in many ways, and it depends on just what you're trying to do in your interface as well. Yeah, triadic is just super. It takes a lot of experience to get this right. It's just three colors that are equidistant to each other on the color wheel. So it would look like a triangle if you choose those colors. It looks great. It helps a lot. And one thing you can do is just use one color as a dominant color and the other two colors as accents. You can also use shades and hues of those colors as well. And that would result in a very harmonious color palette for you to use. Double complementary is sort of the end game when you go for color palettes. So these are 4 colors which are complementary on the color wheel. So it would look like a square if you try to connect those colors. Again, there are so many factors you can play with, and it's just something that you have to learn on your own. The importance of color psychology cannot be understated. It's a field that has a lot of research behind it. We, as humans, we evolved to see colors in different ways. So green is always linked with nature. It's linked with balance, with harmony, with growth. Red is seen as aggression. It's linked with power. It's linked with strength on such a subconscious level. Yellow plays with happiness. It plays with warmth. Again, these are things that we see from our real life. And if you can leverage that well in your interface, it will do absolute wonders. Black and white. Black is traditional, it's modern. White is linked with innocence, wholesomeness, all that. So it's really up to you how you want to contrast and play with these colors. Depending on your app, if you have something like a fitness app, it really doesn't make sense to use pink as a dominant color, because that's just not the users that you're looking for. They want something that is maybe a bit more modern. So you would use something like a dark blue. So it's linked with trust, reliability. So these are things you can play around with. It takes some getting used to, and it takes a lot of research and know-how as well. So in GUIs, why we use color is for these 4 points. It helps enhances readability. So you always want to use contrasting colors, especially for text. It just makes reading a lot more easier. And then consistency, again, when you think of Facebook, we always think of that classic blue that they use, right? So they use that for consistency. Whenever you're on Facebook, the interface always has blue somewhere. So it's consistent. And this also ties into my next point, which is branding. Again, some brands just link colors so well. YouTube has that classic red. Netflix has that classic red and black. Facebook has white and blue. And consistency and branding does so much, especially when you have like a million websites, a million apps these days. getting consistency and branding right will really help your interface stick out, and it'll be a good experience for the user. And at the end, obvious aesthetics sense, getting these colors right is just so much more visually pleasing for the user. It's not off-putting, and it makes for a very welcoming experience every time they use it. So yeah, Kenneth will now explain our case study in detail.
Sharing my screen. Yeah, I think you can see my screen now. So this is the final topic. Hope you can hear me. So, right, context-aware design. So we're going to do this topic along with a case study, so that you better understand how it relates to a real-world example. So, about context-aware design. So, context-aware design is basically structured, well-defined, user-centric process. So it's where your experience collects data about the users and uses it to enhance their usage. So what comprises contextual awareness? So these are some good examples of it. So location-based or IoT related stuff, connectivity, hosts, orientation, brightness. So just so that you get an idea of it, you must have noticed how your phone will give you certain alerts or notifications based on where you are at that location. You'll have localized YouTube feeds, or your maps will give the restaurants around you. So it knows the context. It knows that you are in this place, and so it's giving you location-based data over there. Ritu, I'll explain AR and VR in the end again. And yeah, so connectivity. So if you'll notice how if your phones are connected to Bluetooth or a certain a device which you use often with music, it will suggest the music application. So similarly, there's stuff for all of this. Even when you move your smartphone to landscape, it knows that you've moved it in landscape, and it changes the orientation automatically. Or if you're in a bright environment, your brightness increases. So all of these are good examples of context aware software. So the technical definition would be that a context aware software adapts according to the location of use or a collection of nearby people, hosts, etc. All of this, as well as changes to such things over time. So with time, how you interact with your device will make a more personalized experience for yourself. And this helps a lot, since machine learning and prediction models are integrated into all our devices nowadays. This is becoming very common and basically provides very specific and very easy to use environments. So a good example of this is the Apple ecosystem. So how Apple does contextual awareness is they work across all of their devices, barring none. So if you have, the more Apple devices you buy, you will have certain experiences which are unique between those devices, which you can't recreate in anything else. So this will work across all of these devices which are listed here. So if you have a MacBook, an iPad, iPhone, Apple Watch, HomePod, and an Apple Pencil, all of these devices can work in coalition with each other. So let me describe it in a little more detail. So if you are getting a message, for example, you get that message on all of your devices. You'll get it. Your SMSs will be received on your iPad, on your MacBook, and on your watch. But like Gautam showed in the watch screen, how it does the watch thing is it knows the context of which device you're using. So if you are on your phone, then it'll send you the notification on your phone. But if you're you're not using any of your devices at that point, it'll come on your watch. So it knows the context of what you're using, and it will only alert you at that point, because having a notification on all of your devices is not going to be efficient at all. So that is messages. And similarly, if you get a call, the same thing happens. If you get a call and you're using your laptop, it will ring on your laptop first instead of your phone. Even though you would associate calling with the phone, it knows that you're already on your computer and will show the notification there. And you can always pick up any other device, and since you already are notified about the call happening, so it knows the context of which device is being used at that point. And another good example of this is universal clipboard. So how it does this is I don't think this is there on Windows yet, but how it works is you can copy text, pictures, files, anything on any device, and then paste it on any other device. So conventional copy paste is you copy within your device, like from the browser, and then you paste in your presentation application, for example. But here you can, if for example, someone sent you a WhatsApp message of a picture, you can copy the message from there and you can paste it on your MacBook within your document directly. So it works seamlessly without any setup. So it knows that you're using these two devices. At the same time, it will not transmit that information to any of the devices which are not in use. If it knows that you have your laptop open and your phone open, it will transfer it instantly. So it knows that the context over here is that you're trying to make a presentation. So another good example of this is handoff. So if you're writing an email, this happens across other devices also. Like even the simple idea of drafts, how they work on any mail client, you can continue an email immediately on any other device. But in the Apple ecosystem, it also keeps like the cursor position and the exact text and CC. Everything will be transmitted when you switch devices. It knows that you're already working on an email, so it'll open up the email on your laptop also. So that happens with email, or it can also be, if you're trying to take a picture to put into a presentation, or you want to save it. Obviously, your phone is the one with the better camera, but then you use the laptop for productivity. So all you can do is you can right click and you can click a picture with your phone, which will paste that image directly within your document or on your desktop, wherever you want it. So that is handoff. And another good example is AirDrop. So basically the ecosystem knows all of your devices. So the context here is that you want to share a file within your devices if you want to transmit between two devices, or also to other your friends or family. With in this case, it has to be an Apple product, but you can share your documents, images, anything via Wi-Fi. So instead of using Bluetooth, it will connect the Wi-Fi bandwidths of the two devices and then instantly transfer the file. So it basically knows who's around you. Like this is a host example which I mentioned. So it knows the hosts around. So it knows that there are these many people around you and you might want to share to any one of them. So you can basically share it in that context. So another great example, this is the newest one, which just came this year. It's not even out yet, but they previewed it, and it's one of the most perfect examples of context-aware design. So what it does is basically you can take files from any one of your devices, and you can use your mouse or your trackpad or your keyboard across all of those devices. So all you have to do is just drag from one of your devices, and the mouse will go out of your iPad and go into your MacBook or your laptop, and it will paste. You can just drop it there. So it's not even copy and paste now. You can literally use your mouse across multiple devices, and I think it works up to 4 devices. So you can move your mouse cursor when you're working. You can move your cursor out of your screen, and it will go into your tablet, and it will get whatever you've drawn, or it can go into your other laptop or your other display, and basically it will work seamlessly like that. And another example of this is how they do AirPlay. So AirPlay is like I'm using it right now. So I'm controlling this presentation from another device, and it knows that because I'm doing a presentation, so it suggests that do you want to control it remotely. So this is a perfect example of context-aware computing. So it's something which is being in use right now. So even with this call, I have the chat open on my other device. So all of these things it basically works together, and it knows that you're trying to do a certain task, and it tries to enhance that. So obviously this is not the best way of doing it, the ideal way would be if this was open to all devices, but it's only Apple. That is a problem. But then it is something which enhances the user experience. I don't need to think a lot because it already knows and has analyzed my patterns. So yeah, so with that, I think we can conclude our presentation. So we've covered, eras of interaction design, the relevant interaction styles, fundamentals of interaction Gautam spoke about, and color theory. And finally, we saw a case study of the Apple ecosystem and context-aware design. So yeah, if there are any questions, you guys can ask.
Kenneth, before any question comes,
Yes, sir.
right, I want to thank you for making the session so informative, relevant, and just for the audience, right? Tomorrow, the plan, as per the plan we have, we are likely to have Johnson from Apple. Okay, right?
Yeah.
I don't know. I hope he's sticking to his plan, right? So Kenneth is a staunch loyalist of Apple products, right? I've been saying it from second year, okay? And just for the interested audience, right, go and search for Steve Jobs, right, the original founder of, or the only founder of Apple. He had given a commemoration speech at Stanford, okay? If there is time, go and search in Google for Steve Jobs commemoration speech, okay? It's an excellent speech, only 15 minutes worth. And the final message he gives is stay hungry, stay foolish.
Yeah.
I found that speech really eye-opening. Okay, so for the interested audience, because Apple has design in their blood, I hope I'm putting the right words, right? But this is a limitation, I agree, right? All should be Apple products, right? That is a way of restricting people. I don't approve of that. Yeah. But the design culture is great. Look at this commemoration speech of Steve Jobs, it may help. Okay. Yeah. Maybe if anybody has some questions for some interaction, you can do.
Yeah. So I think before any questions come, I can answer Ritu's question. So AR and VR in two simple lines. So I think I briefly covered it. So AR is basically, you're manipulating the real world. So here you can see that you're using the camera to see just the normal road, and this bridge is not real. So if you're an architect, for example, you can just put your bridge over there and see how it will look. So that is manipulating the real world. Whereas in VR, what you can do, it's not even, you can't even use a good image to use it. So what it does is you wear the headset and you are transported into another world. It replaces your environment completely instead of just augmented parts of it through a phone. So yeah, that is the difference between AR and VR.
Kenneth, there is one question. Right?
Yes, sir.
They are asking, what is your view on foldable displays?
Yeah, I just saw. So foldable displays, I personally I'm not a huge fan of it. But then, yeah, it's a new form of, it doesn't change the interaction much, but it is very contextually aware. So it knows when you're in a folded way, basically it'll have a smaller display and it'll work like a normal phone. And when you unfold it, it becomes a tablet. So it knows the context of use. And I've noticed some very good use cases where even if you're using, if you're seeing a video and you open it up, basically the same application will become full screen. That is useful. But yeah, like someone just mentioned, it's very hard for developers because they are not able to, one thing is they have to make all of their designs responsive across the displays. But since there's no universal standard for it, like if a good example is one benefit of the whole Apple ecosystem thing is they have only like 2-3 sizes of displays for their phones, for example. So developers just have to make it for those 2-3. But Android developers have to make it for a range of sizes. That's the same issue which is happening with foldable because it's already one layer of difficulty to do it for Android. And now they have to do it for foldable displays also. And that's becoming a bit of a problem. If anyone is new to this domain, VR and AR, what would you suggest to start as a beginner to learn things or explore? Okay. So for AR development, there is an application called Spark AR. It's by Facebook. And it has direct integration with Instagram and Facebook. So all you have to do is very, very easy to use. I learned over there only. I was there in a workshop with Facebook for that. And it's they have tutorials on the website. You can note it down. Let me just type it in the chat also. It's called Spark AR. it's by Facebook themselves. So it's mostly drag and drop. They don't emphasize code that much. So if you just get the right assets, you can build filters very easily, and it's you can see the tutorials which they have. It's pretty useful for VR. So I'm working in I'm interning still in a virtual reality company, and it's not easy to do design for VR yet. You can use Unity if you're into game development. People will already know it's easy to make a video game into a virtual reality experience nowadays. But yeah, you'll have to learn something like Unity, or there are some custom. You can use my company's software if you want. But yeah, that is also that's for research purposes. It's good to read up on this stuff before, because VR is more, it's less evolved than AR, even though it's been around for longer. Right, all of you probably already have seen, like, it's more commercial to have AR experiences because everyone has a phone already. So I would suggest you start with AR because it will reach a bigger audience. VR is something you could do research on right now, and you can go into development in a few years, where it's scope of VR and branding. Yeah, VR and branding is used extensively these days. Like most of our clients are, the people trying to make experiences to go with their brand. And yeah, it's a good use case. It's a huge market. Like our advertising in general is very useful. VR provides a very unique experience, very memorable experience. But one problem with VR is it's a one-time thing. You won't see people going into a VR experience over and over, especially if it's like for marketing or branding. It's not often that you'll go into it as often as even AR, because AR you'll use it for measurements, or there is some utility to it. But yeah, the branding in VR use is basically it's a one-time. It's a huge, like, a marketing, but it's very useful. So one thing maybe I didn't mention is nowadays headsets have eye tracking in them, where inside the headset you can track the person's eye, and eventually you'll see like contextual UI, which will, wherever you're looking, the user interfaces will react to it. And also it's very good for researchers, like, if you're trying to study VR, it's very useful data where you can understand where the person is looking in a scene. Yeah. Any other questions?
Great, yeah, wonderful interaction. This audience is highly interactive. That is what we
Yes,
feel.
sir. nice to see them interact.
It's not like your typical data science algorithm audience, right? Where three concepts they are quite influential.
Yeah, VR in gaming is repetitive. So it's designed for repetitive use. But if you see it in branding, it's not. It's not something you don't see yourself going into an advertisement often, right? So it's
sort of one-time investment.
Yeah, it's a one-time, because once it's associated with the brand, the amount of effort it takes to go into virtual reality to experience the brand is a bit of a disjoint, which is still, with time it will change also. This is something like this picture over here is from the new Oculus Quest, and it's a wireless, it's the first true wireless VR experience. So it's something, they made things lighter and they made it wireless now. So eventually maybe we'll reach a point where you can just put on things like a glass, smart glasses, and it will become very easy to access. How can we experience augmented reality and virtual reality?
Can I have speaker details? Speaker details, Kenneth, Karthick. Okay, I'll put his. I am very famous in the institute for remembering people's roll numbers here. Okay, right. This is his email ID. I think it will be spot on. Okay, his ID, his roll number was 18. Harini was also 18. Right. Gowthaman Premlal should have been 40 or 41, right?
40, sir.
40, sir.
COE.
I remember my favorite students' roll numbers here, right? That is the problem for them. COE 16B, not 40, right? Gowthaman, I put it there.
Yes, sir. Yes, sir.
Right? So they will respond to any, if somebody wanted to know your speaker contacts, right? Yeah. So I think Kenneth has lived up to my expectation of branding him as my design guru. Okay. I know, I have learned a lot interacting with these kids, right? Now, HCA, when I started teaching the subject in 2007, was Alpha, Beta, Gamma. Okay.
Yeah.
I think it was teaching such sharp kids, right, where if you push two inches, they will push 20 inches.
Yeah.
Thank you, Ken. Thanks for your time.
I think there's just 2 more questions. There's just answer them.
Yeah, you answer.
Maybe
Feel free to answer.
So yeah, is there anything like MR and XR? So mixed reality and extended reality, I think I mentioned it. It's not there in the slides, but yeah, mixed reality is basically it combines both AR and VR. So like I said, HoloLens is a very good example of it. Can you experience augmented reality and VR? So AR is available everywhere. You can just open Snapchat, and if you put a filter, that is technically AR. Or if you want a proper like a with the back camera, if you want an experience, you can. I think IKEA has an app for. I think it was there in the slides also. And generally, if you have an iPhone or any Apple product, you can go to the Apple website and you can click on any of the products and you can see those products in AR. So that's another good example how they use it in branding, in marketing. So obviously, if you're trying to buy a system, if you're buying a computer, you want to see how it will look right in your office or in your space. So you can just do it in AR and you can see it. And nowadays models are so high resolution that it actually looks like it's over there in the real world. Yeah, good for a product launch. Yes, that's why it's a good one-time experience. When you do a product launch, it's very memorable because people, when they go through a VR experience, I still remember personally this movie Dunkirk by Christopher Nolan. I remember the trailer for it because of the VR experience with it. I tried it out on VR, and it was like you don't often remember trailers after you've seen the movie, but I remember that because of how impactful it was. And yeah, AI and AR, do we have any collaboration in the future? AI, so the thing is, the way AR works now on smartphones is completely powered by image processing and machine learning already. And yeah, they basically, AI would soon happen too, I guess. It's not, I've already seen a lot of reactive environments in AR. But yeah, hopefully we can see proper. I think it'll happen once smart glasses become a thing. When you have smart glasses, it is an AR experience which is always on, and that time AI will be more useful to provide contextual UI while conducting multiple meetings at the same time. Yeah, yeah, that would be useful. It's happening right now. So. All right, so I think we can wrap it up then if there are no other questions. Sir, I think someone's asking for your email ID also. You can give them your contact. He's there, and you can go to the IITDM website and find him also. But yeah, if there are no other questions, we can conclude now. All right. All right. Thank you then. Thanks a lot for staying.
Yeah. Thank you, guys. Yeah. Hope you guys found it useful, informative. Learn some new things. And you guys always have to read up on it at home or wherever you are, and that'll help you a lot in understanding these topics. These are pretty information dense topics. So yeah, please read about it. It's very interesting.
Feel free to contact us via mail if you have any other questions, or you can reach out to us. So, all right then.
Thanks, guys. Bye.